Hello and welcome. Today I want to start adding debug symbol information to the PDB generation of my linker. And there are sort of two steps to this. First of all, we have to extract the debug information from the object file. And so for the symbol information, this is sort of contained in this special section called the debug S section. And then in the second step, we have to also take this debug information, move it around a bit, and then add it to a special, stream it's called in the PDB, where the debugger or whatever wants to process the PDB in the end will find the debug symbol information. Okay. And so the way the symbols are stored in the object file is in the special section, and in the section there's a 4-byte signature, so it starts with the CV signature C13, which is just 4, and afterwards the debug S section continues with a sequence of debug S subsections, and each of these debug S subsections has the following header, so a type, which is 32-bit, and then a length, which is 32-bit. And there are a couple of different debug S types, whatever, debug S subsection types. But the ones we are interested in are the debug S symbol section, the debug S line section, the debug S string table, which is for the file names, and the debug S file checksums. And well, the symbol information, once we've extracted it and put it into the PDB, will probably not work and need a lot more processing to work in the debugger. But I'm sort of hoping the line information will just work, but we'll have to see. And there's one more thing that is a little bit annoying about the debug symbols, namely because the debug S section is contained in an object file, which still has to be linked, they cannot know where the symbols are located. And therefore we have to apply relocations to the debug S section. And there are actually two special kind of relocations, namely the image rel AMD section relocation and the image rel AMD 64 segrel section, segrel relocation. And I have the documentation for those right here. So one is just a 16-bit section index, and the other one is a 32-bit offset from the target, from the beginning of its section. So the PDB in general always works with a section offset encoding, and not a relative virtual address encoding like the executable format usually works with. But okay, so we have to patch in these two relocations in the debug S sections. So let's try to do that. Let's go into the linker. And I already thought a little bit about how to do this, because it is a little bit annoying just from a structure standpoint, because these sections want to have their relocations applied, but they shouldn't go into the final executable, which is sort of a concept that I don't have in the linker right now. But I think the way I'm going to do it is when we are in the main function, which is currently where all the linking is happening. We pass all the object files, we figure out all the external symbols, and then, this is still figuring out external symbols. And then right here, figure out all the sections which have to end up in the final executable. And we put these into this array, sections to combine. And later on, so let's copy this. Here, we iterate over all of these sections to combine. We get This is not the loop I care about. This is the loop I care about. I iterate over all of the sections to combine. I get the relocations for that section. I get the symbol tail for that section, and I apply all the relocations. So my idea for this is that in this loop, I also want to, like, at the same time or afterwards, iterate over all of the debug sections. And so here I would just add the amount of debug s symbol sections, let's say. And then I have to make sure that the debug s sections come immediately after all of these sections to combine for this to work. And I can make sure of that relatively easily by just adding another loop here. So actually, let's sort them first, because that sort of finishes up that whole thing. And say, figure out all of the .debug $s sections and append them to the sections to combine array. Okay, so I grab this section information stuff, and let's say push array 0 of them again, just to get the pointer, debug symbol sections. And then probably exactly like this loop, where we loop over all of the object files, over all of the sections in those object files, we get the section header. But then I want to see if the section header is debug s. So if str_comp or str_comp of section header name is .debug $s for at most 8 bytes. Then I also want to push one of these section informations. And we get the object file and the section header. And then in the end, we can figure out the amount of debug sections in the same way that we figured out the amount of sections to combine here, just by subtracting where we started. It's not sections to combine, but debug symbol sections. Then let's put a warning here. Warning. We append the debug sections, debug $s sections, let's say, after this stuff, so make sure not to allocate anything in arena. Before we did that. Okay. So far so good. And now in this loop that I was talking about, we now also iterate over the debug symbol sections. We get the object file, we get the relocation section, that is fine. If it's a BLSS-like section, don't try to copy the data, sure. Also don't apply relocations, I guess. Copy in the section data. So we do need the section data, I think, later to apply relocations. Let's see. Oh no, we use the image file for that. But for these kind of relocations, we shouldn't use the image file. But okay, we should not copy the section data for debug S sections. So if relocation section something, this is not set, then something. Let's maybe check dump in on one of these object files. So compilation unit 1 obj. I want to see the headers. What do they have? Info remove. Okay, I don't care about that. These are initialized data discardable. Discardable is maybe interesting. Read only. So it specifies some read permission. Can't go by permission is what that means for us. But maybe I can use discardable. Let's check that. Otherwise I could just check the name. Maybe I should just check the name. But it's only debug T and debug S section which are discardable. Let's use that for now. Characteristics is, then we need the discardable flag. Okay, here are some important sections. So if it's anywhere but the debug sections, I'm not going to use it. Relog, image relocation. That's for images. We don't have images here. Okay. The debug directory can be in a discardable. Okay, whatever. Image section mem discardable. Okay, let's copy that. And make a note. For now, we assume only the... Could just check the section image. What am I doing? Yeah. Just section index is bigger or equal to amount of sections. Yeah, that's the best check. If this is smaller than the amount of sections to combine. If this is a .debug sign S section, do not try to copy it to the image. Okay, then we try to apply relocations. So we start out by getting the relocations. Getting the symbol table for the object file. iterating all of the relocations, getting out the members, getting the symbol for the relocation, so what the relocation actually refers to. Then if it's a external symbol, we do something. If it's a static or a label, we do something. Probably this is all fine. But these are referring to the symbol, so afterwards we should know the symbol relative virtual address. And then here we switch, or else if, I guess, on the relocation type. So we should have two more relocation types here. So if let's say if blah, else, then relocation type is, we don't know what yet, so let's copy that. Image AMD section. And actually, probably it's better to have these in one, because for both of them, we have to find the section for a relative virtual address. So let's say if it's relocation type section or relocation type sec, well, then I need the values A and B. And let's make sure I did these the correct way around. Section is A. Yes, section is A. And so we now know the destination, sort of, because it's not this dest, which is in the oh, we have to declare dest here. Not the dest, because that's in the image, but rather the section data. Plus the relocation address. So let's maybe say that here dest is section data. Okay. And we have to find the image section for the relative virtual address. Do we already know that somehow? The symbol relative virtual address is calculated by virtual address offset and object image section. So sometimes we do, sometimes we don't. Probably. For DLL imports, it's sort of weird, but I assume for now that we don't get these. For so maybe let's also have an image section index. Start out at 0, and then here I can just say we have the image section index. For DLL imports, I don't know, man. For BSS. I guess we can calculate it. So symbol image section index. It should just be the image BSS section header minus the image sections. So the start of the array. Is it image? Yeah, image sections. Okay. Then one more time. Right here. Image section index. Very nice. And so now we have the image section index, which I guess means this isn't as complicated as I thought, and I should just make these cases on their own. In the section case, we just have the destination plus the relocation address is for 16-bit, I think, 16-bit section index of the section that contains the target. So one question I have here, is it 1-based or 0-based? Because often these are 1-based section indices. And should I add it to the target or not? One thing I could do, see if anyone cares about this. Dildilkov, this could be it. Some LLVM code, because of course. Write 2 bytes unaligned section ID, but it has it in an RE thing. But here it just takes the sections of the section ID. So let's assume it's not 1-based, and it also just writes the bytes and doesn't add them. Okay. Let's believe in LLVM, I guess. Yeah, it takes sections of section ID. Okay. So we do this and say we need the image section index. And then segrel is, well, 32-bit offset. So we have the image sections. Relative virtual address is just the virtual address in this case. That's what it's called. And then we have to subtract that from the symbol relative virtual address. That should be fine. And that's a U32, and up here it's a U16. And hopefully these relocations are correct. Then, after all of that, we should now have successfully or sort of extracted these debug S sections and added them to okay, we now have successfully extracted these debug S sections, applied relocations. Now we have to add them to the write PDB per object information probably. So let's see that. Right, so this has a debug type information and also this debug symbol information, which I already added. And so here, I assume I have to iterate over the things I just added. So the debug symbol, amount of debug symbol sections, debug symbol sections, amount of debug symbol sections. 32 section index is 0. Section index is smaller than amount of debug symbol sections. Section index plus plus. We get one of these section information. This is in write PDB. Section information structures, I think it's called. Yes. So I can just scroll. Here they are. Let's say a debug section information is not sections to combine, but rather debug symbol sections of the section index. Then we have the section header, which we know as debug S. We have the object file, which gives us the object file index. So U32 object file index is object file debug section information object file minus object files. So that's just the index in the array. I guess this is a size T or whatever. Let's say U64. And so we want to write per object at object file index, and then this symbol information, and we sort of have to do this exact thing. So extract a stream from the section header. So let's paste that. And we get the section header from the debug section information. From the section header, we get a size of raw data and a pointer to raw data. We can use those pieces of information and the object file to extract the debug data. We put set debug data into a stream and assign it to the object file index, symbol information. Okay, then there's one special case here because technically there are sometimes multiple debug S sections. So let's just say for now, if per object symbol information data is already set, we print a warning. Object file %s contains more than one .debug s section. This is currently not handled correctly, let's say. But we just take the last one in that case. Or I guess I could put an else here. Take the first one. Now let's take the last one. So with that, I think we should have the symbol information correctly extracted. Amount of section to combine. Image section index. Symbol image section index. Image section. Image sections. Symbol image section index. Okay. Now, well, first of all, let's test that it doesn't crash or anything. But that looks fine. And then we can go over to adding the information we just extracted into the PDB. So going into the right PDB code. Not sure where the perfect spot is for this information, but probably before the DBI stream. So just here. So we iterate over all of the, where did we do something similar? In the debug type information. Here we have a loop over all of the object files, yeah. And extracted the type information and read out the signature. So we have to do exactly the same thing for the debug symbol sections. But then it's not type information, but symbol information. Now, first of all, let's understand how these symbols look. So I'm just going to iterate all of them and dump these code view debug section headers. I mean, let's copy this, I guess. Debug subsection header. While not, which means it didn't not succeed, didn't fail. Stream read of the symbol information, the debug subsection header, or the size of one of these debug subsection headers. Let's print the debug subsection header. I can just do this like this. And then we also want to iterate the length. So skip the length, which I think I do by stream read from the symbol information, stream read by pointer, stream read array by pointer. Okay. From the symbol information, we read member size is 1 and the count is maybe debug subsection header length, but maybe also not. Let's see. Do I talk about this here? I guess I would want to know about the debug as symbols. I forgot I can't search in here. Because I'm not sure if I have to add the whole length or if the header is contained in it or not, or what is contained in it. Because all of these work differently if I, yeah. Here the whole header's not part of the length. Okay. So yeah, this should be correct. So let's see what that prints. And maybe also I print in the beginning the name of the object file. File name. Or is it called file path? No, it's file name. Okay. And so test. And we can see debug as subsection header. There's one debug as subsection header type F1 and the length 7B. And then there's one of type F100. So that doesn't seem correct. And this length also seems suspicious. So F1 seems correct because it's debug as symbols. But the length is unaligned. Here length does not include the length field itself. All records should start on a 4-byte boundary. Oh no, that's for the other gun. The line information has a similar 8-byte header. Here the whole header is not part of the length in the line information subset. Okay, we have to scroll to that eventually anyway. So let's do the scrolling right now. Symbol record stream. This is what we are going to produce in the end here. But that doesn't talk about line information. Or is this the line information part? Line information. Code view line subsection header. The type of one of these debug is the most important. Debug as lines, debug as subsection. Well, I don't talk about it. So let's make a comment about this. At clean up talk about needing to align, because this very much makes me think that this is supposed to be 7C, and so I need to align myself. Wrong button. Okay, and that looks very plausible. So there are a couple debug S sections in these object files. No, a couple debug S symbol subsections, and then an F2 and F3 and F4. I think yada yada yada. Where were we? Now I scroll all the way back here. F1 is symbols, F2 is lines, it's one line section. F3 is string table, and F4 is file checksums. So that seems all sane. Now, what do we have to produce? Scrolling up all the way back again. It's not far enough. Module symbol stream. The module symbol stream contains private symbol information for each module. A module is more or less a symbol name for compilation unit, but there's also the special linker module, which we won't deal with right now. The information inside the module symbol stream comes from in large part from the debug S section of the corresponding object file. The module symbol stream index for each module is contained in the module information substream contained in the DBI stream. The layout for the module symbol stream is as follows. So we have the symbol information, which is byte size of symbol information, C11 line information, which we don't care about, C13 line information, and then global references. The symbol information. Symbol information starts out with the code view signature, which is 4 again. So let's start a thing here. And here I will, how will I do this? Because now we need one stream per object file, which means the streams here has to be moved up, I think. Push array of struct MSF stream into arena, which is just arena for general purpose stuff. And then we have the current amount of streams plus one stream per compilation unit. That should still work, but let's make sure of that. Not test. That doesn't work anymore. Type test.bat. I want this line right here. Total amount of streams. Oh, the amount of streams is wrong. int max. Which is probably array count streams. -1, so amount of streams, let's say. And then we have to calculate that up here. Where I just allocated them. And now it works great again. Okay. With that, in the documentation, we want to start writing out the streams. So streams of current amount of streams, or let's actually go to that variable and put the module symbol stream base to current amount of streams. PDB stream. Have it copied? No. PDB information module. What is it called? It's not called PDB stream apparently. Oh, PB stream, okay, PDB stream. Plus the object file index.data is, and then we just have one arena, I think, for these. So struct memory arena, object, not object, symbol module symbol stream. I could potentially allocate one per module symbol stream. Anyway, then we have the data is the module symbol stream.base, the data. And actually, we can do this at the very end. No, wait. We need the current, right? Arena current of this arena. Then the size is the arena current minus the base. Okay. Copy out the signature. The debug the symbol subsection of the module symbol string. Again, this has like this sort of layout, so, and the symbol information starts out with the signature. Push struct u32 into the module symbol stream. For u32 is the signature. And here for now, I think this is wrong, what I'm going to do for now, but for now I'm just going to take all of these debug symbol sections and copy all of the contents into the symbol information. So if the type is debug as symbols, which is OXF1, then push struct push data but first, I'm not sure if these debug symbol subsections also have a signature, so let's check that. The way I'm checking this, just looking at it here, I think. So let's put a breakpoint. Type is the debug subsection header type. Then we have a base, which is probably data. And then I just had a remedy command somewhere. Here. And I want to figure out, I guess, the stream where I'm currently at. So stream information dot data exists, okay. Plus symbol information dot offset db. Here we can see that they do not seem to start with a signature. So it's just, it starts out with D3, which is the length, and then 1101 is probably some symbol, which seems to be the name of the object file. And I'm going to put a cleanup here. Add the symbol information to the PDB. I think this is actually what I want to do. Because if I add it right now, but add it wrongly, because I have to iterate all of them to fix up the symbols. But if I don't add any symbols, I don't have to fix them up. And then I can focus on the line information, which hopefully will work after I get all of this done. So let's add a comment here. Reiterate all of the symbols, all of the subsections once for all of the symbols, and then another time for all of the line information related entries. Let's say debug as symbols. Here debug as, I think it's lines. Getting really sick of scrolling through all of this. Debug as string table. And debug as file checksums. Here I'm just going to say for now add cleanup or add incomplete is more accurate. Okay, and then we skip all the data. And then here, after that, we can calculate the size for the symbol information, which we need later on to fill in the header of the module, or like the struct for the module. Anyway, let's just do this. And copy the same loop, but this time we care about the lines. We care about the string table, and we care about the file checksums. Okay. And here, one of these will get a little bit annoying, namely the string table, because I'm pretty sure we're supposed to extract the string table and put it into the global string table used for the PDB, which is the /name string. public symbol index, symbol record stream. Here we are. So, okay, the symbol information we just skipped. Line information. The 13 line information consists of subsections. We have covered that. Debug S lines and debug file checksums, which contain the actual file and line information. Object files also contain a debug string table to contain file names, but inside the PDB, these are merged into the /name stream. There's only ever one debug S file checksum subsections, but there may be many debug S line subsections. In fact, there's usually one per function. The debug S file checksum section contains an array of variable sized structures. For offset in string table, the checksum size, the checksum kind, and then the checksum. Each of these structures is padded to be 4-byte aligned. The checksum kind is one of whatever, I don't care. The debug as line subsection starts with a header like this. Offset in file checksums. So I don't think I have to care about these at all. I can just copy them out. These can simply be copied out into the line data. So we first have to copy out the debug subsection header. Push struct one of these code view debug subsection headers into the module symbol stream, being the debug subsection header, and then allocating the size amount and so U8 test, I guess, is push data, push array into the module symbol stream of U8s, the aligned subsection size. Then we can copy into the dest from the subsection data for the aligned subsection size. Then the string table. This is going to be the annoying one. These have to get to the string table. And I think I have an idea on how to cheese it for now. Maybe I don't. We'll see. And so the debug as file checksums, on the other hand, can stay the same, I'm pretty sure. Because here they are an offset. No, they have to get patched up, right? Because it's the offset in the string table. And when we add these string tables into the global string table, we have to patch up all of the names, all of the offsets, because the offsets are going to be different in the /name stream potentially. So this means what I'm actually going to do, because I think there's only ever one string table and only ever one debug as file checksum. I am going to add these at the very end. So debug as, let's say, just file checksums, and U64 or like U32 is enough. File checksums size, and same for the string table. The string table size, string table is the subsection data. String table size is the debug subsection header dot length, and same thing for the file checksums. Now that we have both of these, I guess the way to do this is iterate over the file checksums, then get the offset into the string table, extract the string, and then have an add or get to add something to the names table. So this would go something like how do these file checksums look? Like this. Iterate all of the file checksums and patch the string offset. Stream, let's make a stream again to be sure that we are not accessing anything out of bounds. Which has data equal to the file checksums. Should have just not abbreviated it like they do, and my brain would be able to type it way faster. File checksums size. And then, yeah, we have this U32. I guess this structure. code view. The structure is like very unaligned. So let's just copy this, put it here for reference, but do while 1, I guess, U32 offset in. Actually, I can just read less, so file checksums. Some entry while we read from the file checksum stream into this variable right here for a maximum of 6 bytes. We have to also skip the checksum size. So let's stream read array by pointer. The file checksums entry for, I guess, the checksum size, one of them, and that's it. Skip the checksum. We can get the string, which is just the string table plus the file checksum entry dot offset in string table. And for now, I want to be done. So let's just access out of bounds if this is out of bounds. Names stream. So now we need to implement the name stream a little bit more correctly than we currently are. So currently we just do this. So we have a name stream which has a signature, hash version, string buffer byte size, string buffer, a bucket count, buckets, amount of strings, and we just fill in all of these values, having a single string in there, namely the 0-sized string, which doesn't even account to the amount. So one thing I'm wondering here is there a special hash function we are supposed to use? Because there's probably one. Otherwise they couldn't recreate or use this table. And it might just be the PDB hash function that they always use. Okay, the name stream should be very much at the start of this. Name stream. The /name stream is the only name stream which is always present. It contains string table, which is primarily used by file names in the line information, which is what we're currently doing. Conceptually, the stream is used to store U32 offsets into a string buffer and set up actual strings. It has this layout. Hash version. 2 different hash functions are defined. And is a version of PDB hash index which returns a U32 instead of truncating to a U16. So this guy right here. And we have to serialize this at the end, but we need one for now, or we could just always keep it serialized. Nah, that's a dumb idea. So I guess we need a hash table here. Well, we have these strings already, they're lying around. So we don't need the string buffer and just can use buckets. Names, char star, stream, buckets. For now, let's say there are 100 buckets, 256 buckets, I mean. Always. This needs growing later. And I guess I'm going to add the name stream at the very end, even after the DBI stream. So the way this would work is for u32 index equals 0, index smaller than the array count of name stream buckets, index plus plus. We hash the string first, so pdb hash index of, I think I have to perform a strlen, yeah, so this is string strlen of the string, and then modulus, so I guess this array count was -1. Let's see what I do in the validation utility. Buckets. I dump out all of the strings, string length, -1. Okay. And so we have u32 hash index is index plus the hash plus the index modulo the capacity of the table. And then we see if entry, which is the named stream buckets, or like the bucket, I guess, of the hash index. If this bucket is not filled in, then we set the bucket to our string. Otherwise, we compare the bucket to the string, and if that's 0, we break. And then clean up growing and failure. I guess it shouldn't fail once we grow. But okay. Wait, this is really weird because now we need to know the offsets in the string table. Ugh, okay. So we do sort of need to start the name stream early. So we have the string buffer. So what I'm going to do is, I guess, push the header already. Man, this is such a mess. Let's do it in 2 views, because I need to sort of selectively copy at this point. In name stream, so this should be in right PDB. My brain is really starting to lose juice here, but we'll push through. Here we have the slash name stream, so struct names stream header. This is something like U32 signature, U32 hash version, U32 string buffer size, I guess byte size. And then U8 string buffer. And this is push struct into the name stream. Of one of these name stream header. And these are filled in here now. The string buffer byte size. We'll start out at 1. And we'll push on the 0 size string. Okay. And now in the part where we just were, we have to, if we couldn't find the string and fill in a new bucket, we have to copy out the string. So push data into the name stream of the string length +1 of U8s. Or chars, I guess, because it's a string. String in string buffer, let's say. And we mem copy into the string in string buffer from the string for the string length +1. And well, we have to calculate the offset anyway to fill into this offset and string table. So let's put an S64 offset in string table starts out at -1. In this case, it is, I guess we could get the string. Let's do it like this. The offset in string table is the string buffer, which comes from names stream header string buffer minus the other way around. The string in string buffer minus the base of the string buffer. And then the same thing in the case where we only find it, where we don't take the string in string buffer, but rather the bucket. Okay. And then we want to copy this whole entry back into the debug as and into the line information, so the module symbol stream. Which technically we could push here because we don't change anything about the header, but I guess we define a new header. We already have this debug as subsection header, which I guess I could just take. Let's say the type is debug as file checksums. The length is the file checksum size. And then we push one of these onto like this. Write out the file checksums header. Iterate all of the file checksums and patch the string offset. I kind of almost want to do this by pointer. So let's do it by pointer. So I can simply patch it and don't have to worry about it. equals stream read array by pointer. Say these from the file checksum stream. We get the file checksums entry. No, we get 6 bytes, whatever. We don't really care how many it gives us, and we say if we didn't get one, we break. We assume we're at the end. And then we skip the checksum, so the checksum size. But we have to be a little bit careful here, because this should be 4-byte aligned. So this plus 6 plus 3 and not 3. So this is the full align size, let's say. And we now subtract 6 from this to get the size that we care about, that we want to skip. And then, because we now do it by pointer, I can simply say the file checksums entry is offset in string table is U32 offset in string table. And I don't care if it fails. Hopefully it doesn't. That's my plan. That's what I'm thinking. Okay, almost done, almost done. The last thing that is missing is when I write out the /name stream, we have to specify the correct buckets. So the bucket count is now array count of names buckets, name stream buckets, and then push struct unaligned. And this is string buffer size. This is now this works like this, yes. So main stream header string buffer byte size is this. And this should work. The only thing that I sort of want to do is to rename this. All of these variables. Oh, this doesn't even exist. Oh, it's name stream headers. Yeah. So it's already sort of implicitly renamed. The string buffer that I have right here. Oh, this is the copied version. The string buffer also has to come from the name stream header. Okay, then it's fine. Then I push array unaligned into the name stream U32 for the bucket count. And we iterate all of the buckets. Which maybe in the future we actually should keep the strings in the string table as U32s. That would make sense. But for now I'm not going to do that. bucket index is smaller than bucket count, bucket index plus plus. So we could simply do a memcopy here. But I'm just going to say for now, if name stream buckets from the bucket index is not equal to 0, then buckets of this bucket index is the offset of the string inside the name stream string buffer. Otherwise it should already be 0, and in this case we also add amount of strings plus equals 1. So we have the collected amount of strings in the very end. Okay, symbols start. String. All of these need the other guy now. Wanted char given unsigned char probably. Wanted char given unsigned char. Sure. Who's unsigned? The string buffer, I assume. Amount of strings. Symbol size is not used. String table size. What is this? String table size. Oh yeah. That's not used. That's actually good that it complains about that. We need to patch that up when we actually care about the sanity check. And I guess the string table should also be char. String table size is not used. Wanted char given unsigned char. Okay, now symbol size and line size is not used. Which makes sense. And we sort of need to get this information from this boy right here, this loop that we just filled in, into this loop down here. Into the module information. Because here we have the byte size of the symbol information and byte size of the C11 line information. Why are these allocated in the arena? Is a question I have. Or because these are pointers to, okay. So how do I do that? Guess I just for now allocate something. Don't make it too hard. Module sizes 332 symbol size 332 lines size. Module sizes is push struct push array into the arena of the module sizes for amount of object files. And then we just cache these two values in here. Okay. And then when we finally fill in these module information entries, we can finally link to the module symbol stream. So the PDB knows where to find the module symbol stream, which we just filled in for this module. And we can give it the byte size of the line information and the byte size of the symbol information. So here where we currently say byte size of symbol information is 0, we now say module sizes of the object file index dot symbols size, and the same for the C13 line information. Line size. String table size is not used. Okay. Now, hopefully this works. Let's try to link it already in the thing. Okay, it didn't crash at least. But probably the validation utility is not going to like this a.pdb. Just was created just now. Okay, so cv dump a.pdb. How are we looking? Oh, IDs are in there, types are in there, but I don't see any symbols, which would be here. Don't even see any modules, which is concerning. But what does validate a.pdb say? Bucket 0 of /name stream contains invalid offset that guy. Okay. So we screw up something when we write in the /name stream. Bucket count and then the buckets for bucket count. I say the bucket minus the string buffer. It's the buckets of bucket index. That should be correct. Because I shouldn't have closed the remedy_bg command. So what do we have? We have buckets for, I guess, OX100. These look very 0 so far. That's good. And then we have named stream names stream bucket. And these are all garbage. So why are they all garbage? How do I not initialize them? I swear to God, it's a C problem, isn't it? Sometimes you fall for C problems. We compiled, or linked, rather. And why does that take forever? What is happening? My computer's completely freezing. What? I guess. CO once it's doing anything again. Okay, it is 3 weeks later, but I'm back. The problem was that I still had this under debug break in here, not in the linker, but write PDB. And so usually what this does is either you're in a debugger and then it breaks there, or you're not in a debugger, but you have a post-mortem debugger, then it pops up the post-mortem debugger, or it crashes. But in this case, I had kernel debugging enabled. So what this was doing is it was waiting for a kernel debugger to attach, and thus it was just completely freezing the system and not responding to anything anymore. Took me a little bit to, well, figure that one out. But, well, I did, and then I decided to go to bed or whatever. And, well, I'm back. I also think off screen I did one more thing, which is to figure out that in the, here we are right in the substreams, I forgot to add the module symbol stream and the module information, which actually tells the PDB where this module symbol stream is that we wrote in. Anyway, I did that. So the index is now in here, the size is also in here, and also the line size, all of which I think we collected above. Anyway, and so yeah, now should be back and it should be working, and we can debug if it now works. So if I do test, I generate these modules, the thing, and then we want to validate a.pdb. And we see the module symbol, the module stream for compilation unit 1 obj ends after C13 line information. We expected global references to follow, at least a U32, which is 0, to indicate that there are no global references. So what this means is that in the module stream that we write in right here, I think, yeah, we have to, in the end, write a U32 0. So we end the module symbol stream right here, where we in the end write out the file checksum setter for the line information, and then we have the line size right here. So immediately after the line size, but before we calculate the size of the module symbol stream, we're just supposed to just push struct 32 0 into the module symbol stream. Symbol stream. And call this global amount of global references at incomplete. So when we actually care about the symbols, currently we only care about lines and not about symbols. We have to fill in this member, but for now I'm just stubbing it out at 0. Let's maybe put the incomplete up front. Okay, let's see if that does anything. The public symbol index is too small to contain its header. That makes sense. We haven't filled in the public symbol index stream. Also, this is not what I want to do right now. But one thing I could try is to run cv_dump on a.pdb. See if this has now some modules. That's what I wanted to know. So that module compilation unit 1, compilation unit 2, and then the linker module. And source files, we don't have lines. Mod get enum lines failed. It's not too good. I think that's probably what's supposed to work. But anyway, let's once try to do validate but dump. Maybe that shows us something about the line information already. C13 line information for module 1 and module 0 just tells us debug as file checksums and nothing else, and debug as file checksums and nothing else. Those don't look correct. But we should be dumping them here, I hope. So write pdb debug as file checksums. Oh, we will write in the type and the length, write out a subsection header, then we don't write out the data. That's probably wrong. So where do I have that information? So here I iterate for all of the file checksums and patch the string offsets. So I have this file checksum stream, yes, which I could use, which is file checksums and file checksum size. I think I just want to write out exactly this data. And we need to align the size, maybe? Not quite sure. So push data this, push array this, +3 and not 3. It might mean that this needs some special padding bytes. Maybe we ignore that for now. We want to write in to the module symbol stream. Kind of concerned that my validation utility didn't yell at me for this, but maybe it's fine. Anyway, so we have the module symbol stream. We want to push U8s of this many. This is the file check sums data, maybe. And we memcopy into the file checksums data of the file checksums and for the file checksum size. And see if that gets us any further. Test. And then a.pdb validate a.pdb dump. That did nothing. Let's look into validate what it does. C13 line information. It, well, yeah, prints debug file checksums, subsection index, sure, which I think is what we see, 0, debug as file checksums, and we iterate over the whole size. So maybe one thing we could do is size %x. What's the subsection dot offset? Oh, that gets incremented. It's maybe 0 or something. That's fine. Okay, HLC validate.c. 0. We've decided these are 0 big, which explains why it didn't yell at us. So we want to know why they're 0 big. And write pdb file checksum size, it should be. Debug subsection header length. So we are printing these right now, supposedly. Oh. If we're not printing anything here, that means we never get here, right? So if I run test, oh no, we do get here. It should be this F4. I'm pretty sure. But we can also check. F1 is debug symbols, which we don't care about right now, and everything else. Debug as string table. Okay, debug as file checksums. It's F4, yeah. And F4 is so read the debug as subsection header and print it, and that tells us that F4 is text 28 bytes long. Not what I wanted to do. Test, I guess. Okay, what am I doing wrong? Didn't print hello. But this printed that the header was a debug subsection type OXF4. What's happening? Debug break. This time that can't go wrong. Right. And I need the test command again. So type test.dat, and we do linker this. What's your problem? Break at write PDB, I think is what I want. Right here. Do we get here? Doesn't know this. What's happening? Are we compiling? It says wrote file. There's a bug in my generation, the PDB in the compiler. Oh, what's happening? Did find the linker. So at the very end here, we call write PDB. We get here. What happens if I step into it? Gets here. Well, whatever. Sure. Writes out the /name stream. Can I put breakpoints now? Does it like it now? It seems to like it now. That's good. So here I fix up all the types. Who cares? This is where I want to be live. Okay. Doesn't simple information. What? Has a side? Oh, the offset's already at the end. At the end. What happened? Oh, a while loop here, which goes over all of them, and prints the subsection headers. Why is this here? Okay, we iterate over all of the subsections once for all of the symbols, and then another time for all of the line information. Okay. That is fine, my friend, but we do need to reset the offset. 1097. In the symbol, reset the offset in the symbol information stream. Symbol information, yeah, stream such that we and reset the offset in the symbol information stream and read all line information related entries. Okay. Symbol information dot offset 0. Test. It crashes. Oh no, it gets to the breakpoint. I guess we don't need this anymore. Stir comp. Okay. Call stack is what I want. Write PDB. This stir comp is crashing. Why? Memory. No. Watch. We have the bucket. And we have the string. The bucket is very null. Okay. We don't like break here, I think is the problem. In 1177. Is the break correct? Yes. Yes. Okay. I guess I run it here. Of course, if I run it in the debugger already, it just works. And test. Compilation unit 1, compilation unit 2. Okay, these are just some prints. And then I want to validate a.pdb. Debug as lines at index 0, offset 0 of compilation unit 1 has an invalid range in section 3. Sure, that's a lot of numbers. How do we look? Contribution offsets. Contribution ID 3. P data. So this is where there's sort of like a confusion between section ID and section index that always happens here. Because there's a section ID, which is the section index, so the index into the section header table, whatever, section table. But the section ID is that index plus 1, such that 0 is an invalid index. I think this wants a section ID, it's telling me, but I probably give it a section index. So let's maybe validate that by looking at what the section ID means, by doing dump bin. I want the sections, so slash headers probably, of a.exe. And we can see we got p data out of it, which is section header number 3, which is index, well, 0, 1, 2. But we want to give it this guy, section header 4, which is index 3. But we give it index 3 and it thinks it's ID 3. Pretty sure. Because, of course, all line information offsets are probably relevant to the text section here, because there's only one code containing section, which means that probably the part in the linker is wrong where we fix up these entries. Should be at the very end here where we apply relocations. Cleanup. Is this correct? Is plus correct? It seems correct. These guys. This is in section index plus 1. And then we do plus 1 because it is requesting a section ID, not a section index. And that might be correct. So link, no, test is what I wanted to do. Then we validate again. And now there are supposedly some lines. You can see There's one debug as file checksums entry. And then here a compilation unit 2. And 3 different lines, 7, 8, and 9. For compilation unit 1, that looks a lot worse. Why does it look worse for compilation unit 1? How do these look? Hello test star.c, test star.c, compilation unit 1. This has lines in like, these should be lines, right? So from 10 to 17. This has 7, 8, 9, so these are probably correct. What's the problem with compilation unit 1 then? And that was again a size issue, so we should probably look at write PDB and print out what we get for length of the debug as file checksums entry. So here I'm just going to print the debug subsection header again. There we can see we get OX28 also. And then I want to see an hello here. I don't get an hello here, which is why it's not working. So why not? Some of these get corrupted, I guess. Oh, I'm not iterating correctly, I assume. Here I have a line size. Do I have a line size here? Yeah. Debug subsection at a length. Seems correct. I read the line section size here. How are these two iterations any different? We read the header. We add 3, we end not 3 to align it up to a 4-point boundary. And then we use stream read array by pointer in both cases. With an alignment with a count of 1 and the size, the aligned size. Okay. So, how do we debug this? I guess a data breakpoint maybe. Like, is it consistent? Seems consistent. Okay, and this has a length of 0, and here it has a length of... Wait, these types are all off also. Okay, this is... seems to be a bigger problem. These types are also off here. Oh, I get it. The offset shouldn't start at 0 because right here we read the signature. This is looking better. This is looking better. Beautiful. Validate that. Those are looking mighty fine. And then the last real test is to see if we actually can single step now. And there it is. Just like a real linker. Beautiful. All right. That was exciting. We can single step. And that's all I wanted to accomplish today. So thank you for watching. And if you have enjoyed it, maybe see you again.